Moving into our section on trigonometry, we're going to start with some angle relationships and triangle relationships on a very basic level before we get into the more complex trigonometry. Just as a review of some of our geometry vocabulary, we have some definitions here for lines, line segments, rays, and angles, as well as diagrams giving examples of each one. So we're going to be dealing a lot with angles, which are formed by rays, lines, and line segments. Some important things to note is the initial side and terminal side that we'll be using a lot when we're dealing with angles, and we'll talk more about something called standard position. Initial side is where our angle starts its rotation, and terminal side is where it ends. And the relationship between those two is important because it makes a difference about whether or not we have a positive rotation or a negative angle rotation. As we see, these two angles have very similar locations for their initial and terminal side, but the direction of the rotation varies, so the angles would be different amounts. Positive angle rotations rotate counterclockwise, while negative angle rotations rotate clockwise. The most common unit for measuring an angle is a degree, and a complete rotation is 360 degrees. We'll also talk about how we can break up degrees into minutes and seconds later. Another common measure for angles is radians, which we'll cover in a later unit. Any angle that measures between 0 and 90 is considered acute. Right angles are at 90 degrees exactly. Obtuse angles are 90 to 180, and straight angles are 180 degrees. An important relationship is complementary and supplementary angles. Two or more angles whose sum is 90 is a complementary angle relationship, while two or more angles whose total sum is 180 degrees is a supplementary angle relationship. So we can use this relationship to find complements and supplements and write algebraic expressions to solve. So for an angle measuring 40 degrees, if we want to find the complement, well, the angle that we're given plus its complement, we'll call angle C, has to equal 90 degrees when we sum them. So if we write this simple equation and we subtract, we find that the complement ends up being 50 degrees. Compared to the supplement, the angle given plus the supplement has to equal 180. With some simple subtraction, we find that the supplement is 140 degrees. When we're given algebraic expressions, we can then use that relationship with the algebraic expressions to write an algebraic equation, allowing us to solve. The angle measuring 6x plus the angle measuring 3x has to equal 90 degrees for the complementary relationship. When we simplify and solve, we find that the value of x ends up being 10. And so we can then substitute x back into both of these expressions to find the measure of both of these angles, giving us 60 degrees and giving us 30 degrees. So the measure of each angle is 60 and 30. Since we have a straight angle, that means it's supplementary, but we'll follow the same logic. We'll set them equal to 180. X equals 18. And then we substitute 18 back into our expression. So our first angle ends up measuring 72 degrees. 4 times 18. And our second angle ends up equaling 108 degrees.